through the scripting command now. Awesome job. Now let's learn a little bit more about what actually just happened, right? Because right now sending transactions is still kind of this magic thing, right? So let's hide our terminal and let's go up to our Explorer. Let's pull this out a little bit and let's go into here. Now, what's important to note is that there's actually a couple different folders in here. Dry run is the folder whenever we don't have a blockchain running. Otherwise, this gets separated by chain ID, and we'll talk about this a little bit later. But if we go into one of these, either dry run or even just run latest, we'll see details about the transaction. We'll see a hash, transaction type, contract name, address, blah, blah, blah. This right here, this transaction section is actually what is getting sent on the chain. When we do forge script or forge create, this is the transaction that we send to that RPC URL, right? This is the API data. If you're familiar with HTTPS posts, this is the data that we actually send. We send the type, which for now, just everything is type 2 because we're in the merge. Don't worry about type 1 for now. We have a from, which is, of course, the from address that we want to have. We have a gas here, and this is the hex value of gas. Now, if we pull our terminal back up, we'll clear this out. I'm about to show you an amazing trick that's going to make your life a lot easier down the line. Cast actually can convert between hex and numbers really easily, and Cast comes built in with Foundry. If we do cast --to base, paste our hex in here and write DEC for decimal, it'll convert this hex value to its decimal value. 0x714c2, whatever, is just this number. And I use this cast to base all the time. You can put some value in here and then what you want to convert it to. And it's a very easy way to see what some value is. There's some other stuff in cast as well. If you do cast --help, there's some other ways to convert different units to each other, like from way, bytes 32, and some other stuff. But to base is going to be one that we're going to use a lot. So we have the gas, we have the value with the transaction. Yes, since deploying a contract is just a transaction, we can add a value to it if we want. In our deploy script, right in here, we would just do some brackets. We would say like value and like 1 ether if we wanted to deploy this with 1 ether. We can't send a value here because in Solidity, you can't set the option value if the constructor is not payable. We'd have to make the constructor payable, but we could send value just like any other transaction. There's this huge data piece here. This is actually the contract deployment code and the contract code in here. We have the nonce, which is going to be that number that's only used once. And then don't worry about access list for now. But this is all the transaction information. And then of course we have our RPC. Now what's not stored in here is a couple other pieces of the transaction. Now additionally, there are these V, R, and S values that account for the transaction signature. It's not getting saved here because it's technically part of this from anyways, they're public values. And these R, S, and V allow our private key to sign the transaction. So what's really happening when we send this, the reason we need our private key is we need the private key to actually sign the transaction that we built. And that's happening a little bit under the hood. So whenever we send a transaction, there is a signature happening. We are signing a transaction and then we are sending it. And that's important for later in the course. They don't save it here, but signing the transaction does happen. When you sign a transaction, it's very similar to doing that hex thing we showed you way at the beginning of the course with the blockchain. Only the private key can sign the transaction. This is how, when we send our data to a node, it knows that it's able to execute it because it's signed by our private key. I'm not going to go too deep into that right now. Now, this nonce piece is a little bit important. Every single wallet has a counter of transactions, which is basically the nonce. Whenever you send a transaction, you give it a nonce or this value, this number only used once, to basically count your transactions. This is really good because if you want to replay transactions, you would just send the same transaction data with the same nonce. For example, if we have a transaction that didn't go through, you'll see that this is in this run latest for the dry. If we run this again, if we hit up, you'll see that if we run our transaction again with our anvil deployed here, we'll actually deploy another transaction. If we go back to our broadcast folder, we see there's actually 2 runs and a new run latest. If we go to our run latest now, you'll see that the latest run now has 0x1. So this increments every single time we send a transaction. Your nonce increments every time you send a transaction. And again, contract deployments are transactions. Now, we went over a lot of stuff in here, but the most important takeaway I want you to have from this is anytime you change state on the blockchain, it does it in a transaction. And the differentiator is going to be whatever in this data field. This data field contains the opcodes to tell the blockchain, hey, I'd like to create a new contract. We're not really going to go too deep into what these opcodes are or this EVM bytecode. We'll briefly talk about opcodes later in this course, but if you want to really learn about opcodes and assembly, we have another course on security coming out that will go over that. But this is the most important thing to take away. When we're in Remix and we're sending transactions with these buttons, we're doing the exact same thing. We're populating the data field of a transaction, but instead of the data being associated with creating a contract, the data is associated with sending a transaction.